Dear students, now we are going to see the subject linear integrated circuit. The subject code is EC3451. The subject under that the topic is basic information about operational amplifier. On completion of this basic information about operational amplifier, the students will be able to explain the ideal characteristics of operational amplifier, summarize the basic information of operational amplifier, and explain the types of operational amplifier. An operational amplifier is also known as op-amp, is a device that is used to amplify a signal using external power source. Op-amps are generally composed of a transistor, resistor and capacitors. There are three popular packages available: the metal can TO package, the dual inline package, that is DIP, the flat package or flat pack. The op-amp packages may contain single, dual or two or quad or four op-amp. The typical packages have 8-terminal, that is 8-terminal dual inline package, or 10-terminal flat pack and dual inline package. The widely used operational amplifier is MU-E741. It's a single op-amp. It is available in 8-pin can, 8-pin dip, 10-pin flat pack or 14-pin dip. The MU-E741 is a dual 741 and comes in either a 10-pin can or a 14-pin dual inline package. Op-amp have 5 basic terminals, 2 input terminal, 1 output terminal and 2 power supply terminals. The pin configuration of op-amp is shown in figure. So it is an 8-pin IC, and the pin number 1 and pin number 5 are offset null. Pin number 2 is inverting input and pin number 3 is non-inverting input. Pin number 4 is negative power supply. Pin number 6 is output. Pin number 7 is positive power supply. Pin number 8 is no connection. An operational amplifier is a direct coupled high gain amplifier consisting of one or more differential amplifiers followed by a level translator and an output stage. This device is used to amplify AC as well as DC input signal, designed for computing mathematical functions such as addition, subtraction, multiplication, integration and differentiation. An operational amplifier is basically a 3-terminal device which consists of 2 high impedance input. One of the input is called inverting input, marked with a negative or a minus sign. The other input is called non-inverting input, marked with a positive or a plus sign. Characteristics of ideal op-amp: infinite input impedance Ri, 0 output impedance R0, 0 input offset voltage, V0 is 0 when V1 and V2 equal to 0, infinite open loop gain AOL, and infinite bandwidth. Inverting amplifier. In inverting amplifier, the non-inverting terminal is grounded and the input is applied to the inverting terminal through the current limiting resistor R1, and RF is the feedback resistance connected between the input and output. RL is the load resistance which is used to measure the output voltage across it. The current through the resistance R1 is given as I1 is equal to V1 by R1, and output V0 is equal to minus I1 into RF. So substitute this I1 here, so minus V1 divided by R1 into RF. So output gain is equal to output by input, that is equal to minus RF by R1. This is the gain of the inverting operational amplifier. The non-inverting amplifier. In non-inverting amplifier, the input is connected to the non-inverting terminal, the feedback is connected in the inverting terminal, and the current limiting resistance is also connected with the inverting terminal, and its other end is grounded. The input voltage at the node A is given as V0 divided by R1 plus RF into R1. So gain is the ratio of output by input, that is equal to R1 plus RF divided by R1. So after simplification, the equation becomes 1 plus RF by R1. So the closed loop gain of the non-inverting amplifier is 1 plus RF by R1. The possible questions are: explain the ideal characteristics of operational amplifier, summarize the packages of operational amplifier, describe the operations of inverting operational amplifier, and explain the operations of non-inverting amplifier. Thank you.